In this video, I'm going to introduce the list data structure in C#. So what is a list? Well, a list is very similar to an array. The main difference between a list and an array is that a list does not have a fixed size. A list, you add in a list, you add elements and remove elements as needed. So like an array, a list can only hold multiple values of a single data type. So we can create a list that holds strings or a list that holds integers, but we can't create a list that holds integers and strings. Like an array, values inside a list can be accessed by their index. And like an array, even though we can grab a single value from a list, lists are very often used as a complete data set. So we will learn how to loop over a set of data inside a list. Here's the syntax for creating a list object. Now in future videos we are going to go over object-oriented programming and go into detail. We will explain this syntax in more depth in future videos, but let's just accept this this syntax for now. The list object is inside the system.collections.generic namespace. And so if we want to use a list in our application, we have to make sure we include this namespace in our project. So at the beginning of our program, we might have a using system.collections.generic statement. So here's the syntax. We use the variable name or the data type name list. So we are creating a list object, and the list object is or I should say the list class is a templated class that can work with any data type. So this syntax we see here with a pair of triangle brackets, this is denoting that this class is a templated class, and we will put whatever data type we want to store in the list inside these triangle brackets. So list triangle bracket and the data type we want to store in the list, then we close the triangle brackets. We give our list a name, any valid identifier, and then to actually build the list object, we are going to use this syntax. The new keyword is our building keyword in C#. We're going to build a list object that holds this data type, and then we're going to put a pair of parentheses at the end of this statement right here. These parentheses denotes the constructor for building this list. And in future videos we will talk about what is a constructor, but let's just go with it right now. So here are some examples. I want to create a list that will hold some integers. So I'm going to create a list object that holds integers. So inside the triangle brackets I put int. I give my list a name, int list, and I'm going to set this variable equal to a new list of integers, and then the constructor is helping build that list. Okay, so this statement right here is creating a list object named int list that holds integer data types. Now if we create a list that holds double values, we're going to see the only thing that changes is the data type that's put inside the list, and we give it a new name. So a list that holds doubles, I'm naming that list double list, and now we're going to build the list object equals new list of doubles, and then we have the parentheses. And again, here's an example of building a list that holds string values. So a list of strings named string list is equal to a new list of strings, and then I'm calling the constructor here. Notice that in all of these syntaxes, I don't have a size of a list specified. When we build arrays, we put in the size of the array, but here when we build lists, we build a empty container that we will then add values to. So how do we add elements to a list? Well, once we create our list object, we can use some methods from the object that help us interact with the list. And the first method we will look at is the add method. So from my list, I'm calling the add method, and I can pass in a value of whatever type the list holds. So if this was a string list, I might add a string value. If this was a double list, I might add a double value. But since I created an integer list here, I'm adding some integer values. And I'm calling the add method 3 times, adding 3 values. Let's see what this looks like. When we first create our int list object, we have an empty list. Its size is 0, it has no values inside it. After I call the .add32 statement, I have added the integer value 32 to my list, and now I have a single value in the list, and I have an index for that value. So int list at index 0 would give me the value 32. Now when I add 16, what do? I am adding a new element to the end of the list. So if I look at my list here, I had the value 32. I've expanded my list by adding a value 64 to the end of the list. And that gets a new index. It gets the index value of 1. And as we add elements, the index of the list will just keep on increasing. Next, I add the value negative 101. So I'm adding a new element to the list. It gets the next index, and so on. So like an array, we have a data structure that holds a type, and that type has an associated index. But unlike an array, we get to build the list as needed. Here are some other useful methods and properties of the list object. In an array, we use the length property to determine how many elements are in the array, so that we know the size of the array using the length property. Well, in a list, the length property is called the count property. So .count from a list is exactly the same as .length from an array. So .count of a list will return how many elements are in the list. So as I'm adding new elements to the list, my .count value is growing. We looked at this method already, the .add method. The .add method takes some value of whatever data type the list holds, and this .add method just adds that value to the end of the list. There is an insert method, .insert, that takes an index value and some value to add to the list. So I can use .insert to insert a value maybe between some existing elements. So .add adds a value to the end of the list. .insert lets you insert a value at the beginning of the list, in the middle of the list, or at the end of the list. The .remove method will try to find a value in the list and remove that value from the list. So we can use the .add method to make a list grow. We can use .remove method to make a list shrink. So the .remove can let us take values out of a list. When you take a value out of the list, all of the indexes kind of collapse down one that come after whatever the removed value is. So when you remove a value, you don't leave an empty hole. You actually just pull that value out of the list. The .index of will return the index of a certain value. So if you're looking for a location of a value in your list, index of can help you find that. And the .contains method returns a Boolean value. It returns the value true if this value is found in the list. It returns false if it is not. So .contains can be used to determine is a value in my list. And then the .index of can tell you where that value is in my list. So all of these are useful methods when working with lists. Let's look at how you can iterate or loop over a list. Well, this process is basically the exact same as iterating over arrays. So you can iterate over a list by building a counter-controlled loop that loops over the indexes of the list. And so here I'm setting up if I want to loop over all the values inside my int list object, well, I can set up a counter that starts at index 0, because the first index value in a list is always 0. And we're going to keep increasing my counter by 1 until we get to the .count index. .count, remember, returns how many elements are in the list. So if there are 3 elements in the list, .count will return 3, and I want to loop from 0 to 2, 0, 1, 2. So I is less than the count of the list. When you set up this counter-controlled loop, then to access each element in the list, you take the list name at the index I. And when I is 0, we're accessing the first element. When I is 1, the next, and so on. Now, as a reminder, just like arrays, when you iterate over a list by index, you have read and write capabilities to that list. So I can read off values in the list, or I can modify values in the list. If I only need to read values, then I have a second syntax called using the for each loop, and this is how I iterate over a list by the values. So for each integer value in my int list, this is the syntax, then the variable name val, this can be any identifier I want. This could be x or y, but I named it val. For each value in my list, I'm going to grab the value out of the list, store it in the val variable, and then I can print it or sum it, or I can do work with that value. But I can't change it. Iterating by value does not give me a location to modify the value. I can only interact with the value. All right, hope this helps kind of introduce the topic of lists. In the next video, I will have an example of working with lists.